let's try to solve another Leetcode problem. 738 monotone increasing digits. So we are giving an integer, so which has monotone increasing digits if and only if each pair of the adjacent digits x and y satisfy x and x less than or equal to y. So we are giving this integer and we're gonna return the largest number that is less than or equal to n with monotone increasing digits. Yeah. So what is this meaning? So for example, if we are giving an integer 10, so what's gonna be the largest monotone increasing digits less than or equal to n? So it's gonna be 9. And for this example, 1, 2, 3, 4, it is okay. Yeah, because this 4 is less than or equal to 4, 3 is less than or equal to 3. Yeah. Because this 3 is less than 4, this 2 less than 3, 1 less than 2, it meets the condition of monotone increasing. And for this one, 3, 3, and 2, yeah, because this 3 is bigger than 2. So what's gonna be the largest? It's gonna be 2, 9, and 9, because 9 is bigger than 2, this 9 is bigger than this 9, bigger than or equal to this 9, so this is okay. Yeah. So how can we find that? If we are using a brute force, like we're gonna check from the largest number n, and for each time we're gonna reduce 1. So for example, 3, 3, 2. Next time it's gonna be 3, 3, 1, until we get to 9, 9, and it meets the condition of monotone increasing, and then we're gonna return this number. But that's gonna be time limit exceeded because it's gonna be a really big number, because n gonna be 10 to the power of 9. So this means the time complexity can be 10 to the power of 9. Definitely it didn't work. But how can we solve this problem easily? So instead of we are searching the largest number according to this integer n, so we're gonna construct this number. We're gonna construct the largest number, and the constructed number should meet the condition which is gonna be less than and equal to n. But how can we construct such a number? So we're gonna use the condition of 1, 1, 1, 1, 1 to construct it. So for example, if we are having integer n equals to 10, so what's gonna happen? So we're gonna prepare a 1, and then we're gonna use this 1 plus 9 times. So if 1 is less than or equal to 10, it is okay. We're gonna plus a 1, and then we're gonna plus a 1. And how many times we need to plus this 1? Definitely we're gonna need to plus 8 times, and then this number gonna become 9, and 9 gonna become the largest number. And similarly for this 1, 2, 3, 4. Yeah. So from the beginning we're gonna prepare 4 numbers. So those 4 numbers are gonna be 1, 1, 1, 1. Yeah. So 1, 1, 1, 1 meets the condition. It is less than this number. Yeah. So what are gonna next? So next we're gonna, if we are going to plus another 1, 1, 1, 1, definitely it's gonna be bigger. So this is yeah, this is not okay. But we can still reduce this number. Instead of 4 ones, we're gonna reduce it and make it 3 ones. Yeah. We just want to check if it works. If we are going to use 1, 1, 1, 1 plus another 1, 1, 1, it's gonna become 1, 2, 2, 2, and this 1, 2, 2, 2 is gonna still less than this number 1, 2, 3, 4. So what we're gonna do? We're gonna plus 1, 1 from here. So it's gonna become 1, 2, 3, 3. It also meets the condition. But if we are going to plus a 1, 1, it's gonna be bigger. So next we're gonna plus a 1. So 1, 2, 3, 3. It's gonna plus another 1. It's gonna be 1, 2, 3, 4. So this is going to be the largest number. If we are going to plus another 1, it's going to be 1, 2, 3, 5. It's going to be bigger. That is not okay. That is why we're going to return 1, 2, 3, 4. So now we're going to use this kind of idea to solve the problem. So we're going to prepare some 1s and the result. So we're going to prepare 9 1s, and the result is going to be starting from 0. So our condition is that we are going to construct this number. So the idea is that we're gonna check while the ones plus the result is less than n. Yeah. So the result gonna plus equal to the ones. So finally we're gonna return, yeah, so finally we're gonna return the result. Yeah, but currently this one's gonna be a really big number. Definitely it didn't work. We also want to reduce the ones. So from beginning it is 9 ones. So what about we're gonna prepare 8 ones? Yeah. So for each of the time we're gonna use a for loop. So for I in range 9, yeah, this means we're gonna prepare 9 times. So finally the result gonna plus ones. We're gonna check how many ones, and this ones must meet the condition. Yeah. So here, if this ones plus a result is more than n, definitely we want to reduce the ones. So the ones can be reduced by divided by 10. So the ones gonna become smaller and smaller until it didn't meet the condition. This means it's gonna be less than or equal to n. So if it didn't meet the condition, if it is less than or equal to n, we're gonna plus so the result gonna plus the ones. Yeah, and for the next for loop we're gonna continue to check if it didn't meet the condition. Yeah, if it is bigger, so the ones gonna become smaller. And then if it go to the while loop, we're gonna plus the ones to the result. Let me just run it first. Yeah, now as you can see, it works. Let's just use some examples to explain it. So for example, the first example is 10. So what's gonna happen for this 10? First of all, we're gonna have a for loop. It's gonna loop 9 times. Yeah, so this ones is with 9 ones plus the result, it is 0. It's gonna be a big number. Definitely it's gonna be more than 10. So what are we gonna do? We're gonna reduce the number, reduce it smaller and smaller until it meets the condition. It's gonna be less than or equal to n. If it meets the condition of less than or equal to n, so what's gonna be the final result of ones? So the ones gonna become only 1. Yeah. If it is only 1, what's gonna happen for the for loop? So after the while loop, so the result gonna become 1. Yeah. Now for the next for loop, we've already met the condition. It is less than or equal to n because n is 10. So we're gonna plus another 1 and plus another 1. And how many times? It's gonna be 9 times of 1. So finally, this number gonna become 9, and 9 is gonna be the biggest number. Yeah. Now what about let's just use the second example. So for the second example, so all those ones are gonna become smaller and smaller. So if it becomes smaller and smaller, what are we gonna do? Yeah. So if it becomes smaller and smaller, first of all, we're gonna have 5 ones. So, but 5 ones it is bigger than n plus the result 0. It is bigger than n. And then we're gonna prepare 4 ones, right? So if it is 4 ones, it is okay because it is 4 ones. It is less than or equal to n. So the result is gonna be 4 ones. Yeah. Now we're gonna go to the next for loop. Yeah, because this, yeah, so currently result is 4 ones. So 4 ones plus another 4 ones, because once it has 4 ones. So it's going to be 2, 2, 2, 2. It is bigger than n. So what are we going to do? We're going to reduce the ones. So the ones are going to become 3 ones. Yeah, definitely it's not 4 ones. But if it becomes 3 ones, definitely this ones plus the result, it is less than or equal to n. This is why we can directly calculate it. So the result is going to become 1, 1, 1, 1 plus 1, 1, 1. It's going to become 1, 2, 2, 2. So this is the result. Now we're going to use another for loop to check. So while we are using another for loop to check, so this ones plus the result is the 3 ones. Yeah. So if this number plus 3 ones, it's going to be, become bigger than this number n, 1, 2, 3, 4. So what are we going to do? We're going to reduce 3 ones with 2 ones. Yeah. If we have 2 ones, it means it is okay, less than or equal to n. So we're going to update it to the result. It's going to be 1, 2, 3, and 3. So for the next time, we're going to plus 1, 1. It is bigger than n, so we're going to reduce it to only 1. So it's going to become 1, 2, 3, 4. So the result is going to become 1, 2, 3, 4. So for the next time, it's going to plus a 1. So it's going to be 1, 2, 3, 5. But it is bigger than n. Yeah. So if it is bigger than n, what are we gonna do? So the 1 is gonna become 1 modulo 10, it's gonna become 0. Yeah. So the result gonna be plus so the result gonna plus 0. So 1 2 3 4 plus 0 plus 0 plus some 0, it's gonna still be 1 2 3 4. So this is why it is a 1 2 3 4. And similarly for the third example, so first of all it's gonna become 1 1 1, and then it's gonna become 2 2 2, it meets the condition, and then it's gonna plus 11 until it becomes 2 9 and 9. So this is the greedy idea. So from the beginning we're gonna construct several ones, 9 ones, and then we're gonna check how can we construct such numbers which is gonna be less than and equal to n. Yeah, maybe you're gonna think maybe this number cannot be so big. We can make it a smaller number. This is also possible, but normally it is not necessary, because for this one the time complexity has already become really small. It's gonna be n squared, so n gonna be 10. Basically it's gonna be 100. It's gonna be a really small time complexity. Normally we don't need to do that, but if we were to do that, maybe here we're gonna use integer with 1 times how many ones, it's gonna be length of the string n. This is also okay. Yeah, instead of we prepare 9 ones, what about we prepare the length of the ones? It depended on the length of the numbers. We don't need to prepare 9 ones. Yeah, if we don't need to prepare 9 ones, definitely we can reduce the time complexity from here, because from here we don't need to divide it 10 every time if it didn't meet the condition, because we've already prepared a smaller number. So this number gonna be smaller enough for us, because it is not 9 ones. Maybe for this number we're gonna prepare 2 ones, for this number we're gonna prepare 4 ones, for this number we're gonna prepare 3 ones. So this is also okay. Yeah, I think that's all about this problem. Thank you for watching. See you next time.